Today we will be talking about the CDN. So this is a topic that we are going to cover. That stands for Content Distribution Network, and also we call it as a Content Delivery Network. So both the names are actually referring to CDN. So what exactly is the content distribution? We have, like, we are using cloud services, and cloud services, when we talk about Amazon, let's say AWS. So Amazon is now having its presence globally. So we are using a term region. Region means the geographical regions where this has a presence. They have the data centers, and data centers on these regions are known as availability zones. So we are keeping our kind of data onto the cloud, and then all the customers throughout the globe are using these cloud services. So the problem here is maybe you are deploying your application onto the cloud, which is somewhere in one part of the world. Let's say you are let's say American based company, and you are using a cloud that is deployed there. Now you may have a customer globally, maybe somewhere in the far Asian region. Now when they access your services, then they will feel some kind of latency. Latency means they will find some time because their distance is far. So whenever they make a request, their services are not that much good compared to customer who are residing near to the location where the data centers are there. So if the customers are far, the response will be late. If the customers are near to the data centers, then the response will be fast. So this is the issue, and for that we have a concept called content distribution network. So first we will understand what exactly is the concept, and then how it is implemented using a cloud, and how it is implemented using a AWS and Microsoft. So in the Microsoft we call it as a Azure CDN, and in the Amazon we call as a AWS CloudFront. So CloudFront is an application of CDN. So this is how the entire thing started, why we realized the need of CDN. So it started from the year 1998. So it's a very short history, just to understand, does it really have a meaning? So in 1998, the concept of CDN has actually realized when we are moving towards using the computers. Okay, so by that time, internet has already taken place. People are using internet, and also the company are actually moving to use internet for the business. So it has been realized that the fast-hitting customers are not getting services properly. So in order to solve the problem, the CDN has been proposed. So CDN is basically they are providing kind of services very close to the customer, so that whenever any request is raised, the service is provided at a very faster pace. So it started in 1998. Then some companies like Akamai, Mirror Image, it's an American company, very popular for the CDN services. They have come forward and they have started setting their network around the globe. They have invested a big amount, and in a various part of the different regions, they have built up their infrastructure, and they are saying that there is no need for any company to build their own infrastructure. They can simply take our infrastructure, pay to us, and then on behalf of you, I will give the services to the customer. This is like, and as the time passes by, the more and more we are depending on the internet, the more and more we are depending on the kind of bringing the business onto the computers. Then e-commerce, m-commerce come into the picture, and we have realized that CDN has having a more impact and more required. So similarly, we have some flash crowd event. Flash crowd event is a scenario when we have a kind of voluminous demand at certain period of time. For example, this 9/11 happened, and then people are searching for all the reasons, and so it has been found we have certain events where the customer demands rises, and sometimes it is found that on this duration the servers are not capable to fulfill the customer request, and they become dumb. So in order to handle this kind of scenario, we need to manage this. So one thing is, either we can enhance or increase the capacity of server so that many demands can be fulfilled. This is one thing. Other thing is, we can identify where are our kind of customers, from where the requests are coming, and then we can provide the servers to their regions. The entire load will not come together at one place. Okay, so these are the different options are coming out. So it is not possible for the company to build the infrastructure around the globe. Okay, they don't have that much kind of, every business don't have this much budget. So they simply take the services from the well-known players who are already having this network and providing the service. So web usage has been increasing, and we have now developed server for each kind of services. And then we have identified that the more we are having the request on any server, the one solution is we can go for web server farm. Web server farm is, instead of having one server, we can go with the multiple servers, so that whenever there is a huge demand coming at any point of time, the entire load will be balanced. This is called load balancing. So it is not financially feasible for every company to build this content infrastructure in every part of the globe. So we are going for this CDN services. So let's see that how exactly the problem is coming. So whenever any request is made through the internet, it has to travel through various network. So many things are actually responsible for your request. What kind of bandwidth has been used to deliver your request? How many networks have been in place to reach to the server? Okay, so for example, this is a client which is demanding any service from this server, and it has to go through this entire network. Then only your service will be given to you. So this is dependent on the bandwidth performance. It is dependent on the network which is available, and then it is also dependent on the capacity of the server. So all these factors are basically responsible for the performance. Means how much time will be taken will be dependent on all these three factors. So one thing is kind of suggested that we can increase the capacity, so that now the load is on not on one server but on many servers. But even if we do with this option, entire performance is not going to increase, because still it has to go through these, and this is again affecting the performance. So if there are a lot of congestion on the network, then definitely you are not going to get your reply in a faster pace, right? So this is one solution, that instead of using one server, you can use multiple servers, so that if you are having R request and if you are using N server, then the total load will be R by N, enhancing the capacity of server so that the entire load will be distributed. It is called load balancing. So with load balancing, somehow we can handle the situation, but the performance is not going to improve. But still the performance is not improved. Why? What are the other factors which are responsible for the entire performance? You can see here the internet, which is actually there, and the bandwidth which is used. So if we do a kind of calculation that how much delay will be there to get a response from this kind of scenario, then we have something called transmission. So I'm not using much mathematics, I'm using a little formula. So transmission is defined by the total data to be delivered divided by the bandwidth. Okay, so the transmission time is basically a delay here, means how much transmission time it will take to send the request and then get the reply back. So we call it as a round trip time, and round trip time, the more the round trip time, the more delay is the response. So let's say this is some scenario given to us. This is the capacity or capability of this device we are having using. So if we find out the performance here, so it has to pass through these wires to the network and then go to the server to get the request and get the required data. So the total delay will be dependent on the internet delay, and also based on the bandwidth that we are using for this internet LAN. So here you can see that this delay, the delay because of the LAN is this much 0.015, and the delay because of this access link is something 1. So the entire delay is 2 plus 1 plus 0.015. So this is more than 3 seconds, which is considered to be uh, a very significant time when we are doing business onto the online. So this is much delay, and we want to reduce this time. So this is said to be huge, though it's appears like 3 seconds, but 3 seconds means a lot in the internet world. So the one solution is, instead of enhancing or increasing the capacity here, because if you increase the capacity here, still it has to go through this, and it will not give the actual requirement, means it will not improve the performance. So why not we can just make one cache here. It's a temporary storage for whatever data is needed. We will keep it here. So whenever any request is sent for the server for any data, so instead of going here, we can get all the things from here. So we are saving the data locally. Okay, for example, you have been observed when you are trying to log in to any website. Let's say you want to log in to your Rediff mail account or Gmail account. So if it is a new computer, you may find that it will take some time, but the next time it will be very, very fast. So how it is happening? Because whatever the request you are sending, it will save locally in your, in the cache as a cookie, right? So next time when you send the same request, you will get it immediately, right? So we have IP address, right? So IP address is identity given to every machine, and this IP address is a unique for everyone, for every machine which is a part of internet. So if any machine want to be part of internet, it have one IP. Let's say if you want to access any machine, let's say you want to access Yahoo server. So Yahoo server is having one IP address, something 120.12.10, something is there, okay? But it is not easy to memorize these IP. So what is easy is letters. So when you write yahoo.com, so yahoo.com need to resolve with some numbers, this IP address. So when you write this, it goes to the server that is called DNS, domain name server. So it will resolve, it will map this name with the IP. So when you send the request, it will go there, and then as a response, it will give you back the IP address, and then IP address will be, by using the IP address, you can reach to the actual server. Okay. So first time only you have to make a request to DNS. The next time that IP is already stored in your cache. Next time, every time you don't need to go to the DNS and asking for, could you please map me this name to the IP address? Only one time it is required. So similarly, when we are using this kind of cache, so the very first time when any request is actually made from any of the machine for any data from the server, so initially the data is not there, so it will go here and fetch the record, but next time when it is requested, it will be available here. So as a whole, sort of performance enhancement we can see. So any request, so GET is a kind of request for any data is made, and then you have a scenario here. If the data which is requested is not available here, then you have to fetch the object from this server. Okay. So let's say the first scenario is it is not available. So you have to go through the entire process that we are doing earlier also, and then the data is here, and then supply to the client. This is done. The second scenario is you are asking for any data, you make a GET request, and it is already available there. Then simply you can give the reply. So the entire transmission time which is going to this LAN and then to this access link and then to this network internet will be avoided, and overall performance is enhanced. Now still we see that in many cases we are not finding the required data onto the cache, then it has to go there. So let's say the hit rate is 0.4%. It means out of 10 requests that is made, 4 times it is found on the server. So somehow we have enhanced our performance. Somehow we have reduced the delay time. But this is not a very foolproof kind of solution. Why? We will see here. One thing is we have realized that with the cache, the performance can be enhanced, not fully, but somehow we can enhance the performance. So why not to just deploy the cache everywhere? This is one solution. But we have some issues with this kind of approach. What is the issue here? So if we look to whatever solution we have seen so far are not foolproof. if you go with the server form means if you enhance the capacity of the server, then you can decrease the load onto the server, but still you have to face the congestion, network congestion, and the performance of the link that you are using and the bandwidth that is available. So still the entire thing is not solved. This is one issue here. Now caching proxies. So when you are using a cache system, means you are caching, then it is not actually applicable to all the users which are actually available globally. So wherever you are placing the cache, only that amount of users can be getting a better performance, but it is not solving for the entire customer base. Now content providers are also there is no much control on the cache by the content provider. Content provider is the origin where the actual data is residing. So these providers are not having a full control on the cache. They are simply providing something to the cache. Cache is storing the data and then supplying for the further request. But if there is some changes happening on to the real data, then you are not able to get this. Means there is no communication. Yeah, you get the last one. Means there is no controlling, there is no communication. You are just providing a copy and then providing the copy to all the further request. So this is again, because if you need a kind of latest data, then it should be updated all the time, but there is no communication happening for any updates. And also we have accounting issues because there is no communication, there is no controlling of the provider onto the cache. So the provider cannot get that how many requests are made for what kind of data. Means there is no login has been done. Okay, what kind of data from which part, because it is only providing the services to one region. So we are not getting all this logging information. Now logging information is always important for any business, because with the help of logging information, the business can do a sort of analysis and they can make the strategies for the business. For example, if you are into a business, you are selling some online things, like for example maybe some hosiery kind of thing. So you can find out what are the peak time, means on which duration you get the maximum sale, what is the age group, what is the gender. Based on that you can make your policies to enhance your business. So logging information is always important for the business, but we don't have this kind of service available in this scenario. So this approach is not a foolproof, not a very efficient approach. So we move to the CDN. Now CDN is a very well framed architecture which will kind of fulfill all these issues. Means whatever the problem we have seen here, it's now removed by using this CDN architecture. So what is the basic idea? The basic idea is that we have this original server, means the provider who actually contains the real data, and then this is the client. So whenever any request is to be made, it is not asked from the original kind of provider, but we are keeping some replicas of this. Now replica and cache both are different things. Okay, so here when I say replica, means they have a mutual coordination. In the cache we are not having any coordination. The coordination means now we have some kind of algorithms are running and they are managing the status of data. Means if any update is done on the data, it will be updating here as well. Let's say this is some data here and data is copied here, right? At any point of time, there is some kind of modification in the data which is here, then immediately it will pass on this information to all the replicas. We have just distributed the entire data to different regions, and now every server is handling the request coming from the local region. So what is the advantage? We have some advantage of this. Advantage is now, because the request is served locally, so the performance is very, very good. It has not to go through the internet. So what exactly is the CDN? We understood that we have a kind of geographically distributed servers so that we can provide the services at a very faster pace. Why? We want to improve the performance and improve the scalability. And how it can be done? So it can be done by doing the replication of the containts. So we have some terminology we are using here. Containts are basically the object that is to be provided to the customer. It may be any file, it may be any object like audio file, video file, images. Okay, all these are said to be contained. Content providers is the original holder of this content. Okay, so the main server, you can say, is called content provider. And origin server is basically the machine which is actually holding all these data to be provided to all the customers. And then surrogate servers are basically the terminology that we are using for our replica machines. Duplicate machines means replica machines. So these are the terminology that we use in the CDN. So this is a scenario. This is somewhere in the, let's say, north part of the USA. This is established one company, and then the customer is throughout globally. So they have the CDN infrastructure is there, and they are using the services. So now the customer can simply make the request. They cannot go to make a request here. They can simply make a local request and get all the data. So the performance will be enhanced. So who are the players? So one is the content provider, who is the actual owner of this, and the other player is the CDN, who is actually providing the services. So CDN are the big companies who have their big infrastructure throughout the globe, and they charge to these providers for the services. And because it will require hardware and software for developing this infrastructure, so they can contact to these vendors, and then hosting providers are also there, which are working locally on the different regions. So these are the basically 4 providers which as a whole make the things very feasible and reasonable to be available to all the customers. So this is another scenario. So how actually this CDN distribution works? So we have the actual server, the provider of the content. They have to first make an agreement with the CDN distributor for the services. So entire thing will be replicated to this main server, which is acting as a primary server. And then through this, it will decide that how to distribute the data to other part of the globe. So this is how, this is the main server which is replicating here, and then based on different algorithms, this is distributed to different servers. This is again the different figure for the same thing. We have this is a content distributor, and then we have different surrogate servers are there, which is fulfilling the requirement or demand for the clients at different part of the world. There is one thing that I am just using the name, but we will be demonstrating later in our discussion, something called Route 53. So normally we use DNS. DNS is a kind of server which resolve every name with the IP address. So in the AWS environment, we are using AWS DNS. We are calling as a Route 53. So 53, they have named 53 because DNS works on the port 53. So that's why they have named Route 53. And this is basically mapping the request of the actual server to the replica server. Okay, this is what we are doing with the DA. So just I have used the name, but later I will see in detail what exactly the Route 53 is doing for us. So how actually the things are working in the CDN. So whenever any request is made to access the data from the original server, so this request is intercepted by this network environment, by this CDN infrastructures. They will intercept the request, and they will deviate the request from the origin server to the replica. Okay, so because we don't want the request to be delivered to the actual server, but to the local, okay, to the surrogate. So this is intercepted, and then it is redirected. So then the entire thing we understood what exactly is happening, but now we have some issues. So we have many algorithms are there to implement this idea. We'll just name a few algorithms to understand. So what are the issues are there? For example, we have said that the replicas to be made. So we have original server is there, and with the original server we make a replica, and these replicas are provided to the surrogate servers so that the local needs will be fulfilled. But how you can update all the updations that is going. So this is one thing to be taken care. Let's say you have made at any point of time, let's say at 10 p.m. you have made a replica, and let's say at 10.2 seconds there is one update happened at the original server. Then what is the algorithm we have using to provide the latest data to the customer? This is one thing. Okay, so for this we have many algorithms are there which actually doing different mechanism to keep the replicas always updated. The second issue will be, for example, if there is a request made to access some data, and the distributor who is actually diverting to these surrogate servers, now he find that there are two servers which are very near to the customer, then to which server he must direct. So let's say one request is made, and now there are two nearby servers are there. So to which server I should direct, means the one who is directing. So to which server it must be directed. So again, we have many algorithms. One says we need to find out which is more closer, but this is not very good kind of algorithm. The other says you need to find out who will provide you the least latency. So least latency means you have to find out the round trip time. So we have server A and B acting as surrogate server. So the one who is directing, he first realized that if it will send to A server or to B, then where is the round trip time is minimum. So first he has to do this calculation, and then only he will say go to A or B. Okay, so there are many issues are there, and for this we have number of algorithms are there. Then issues of content management, that how the entire content to be managed. Either you are duplicating the entire server content or you are doing a partial duplication. So entire means whatever you are having in the original server, you just duplicate everything to the, or you can do partially, or you can always ask the user to make an initial request to the actual server and then pass on to the textual data, and whatever is the heavy data is required, that is kept at the replicas, because the time consuming will be for this heavy data, means when you are type of accessing like a heavy graphic file, video file, audio file from the far location, then it will take time. So it is good not to provide these kind of objects from the far location, provide these objects from the nearby location, but the textual data you can provide from the far location. So that is called one strategy. That is also one strategy, that instead of providing everything from the local, just ask them to get the textual data from the far location and the heavy objects from the nearby location. So again, these all strategies are mentioned here. So these are the issues that to be taken care when we build a CDN architecture. One is the request routing infrastructure, that how the request to be routed. If there are two surrogate servers are nearby, then how you will find out that which surrogate server will be the best for any client. And then distribution, how you are going to distribute the entire data onto the server. Are you going to replicas of the actual copy, means fully or partially? And then accounting infrastructure means how you are going to do the log management. Okay, all these issues should be taken care when any CDN architecture to be developed. So this is DNS redirection that I have said that. So when you are redirecting, then these are the different options are there. One algorithm is based on round robin. So if there are two nearby surrogate server, just give one request to A, then to B, then to A, then to B. This is called round robin. Then least loaded CDN server. The other observation is that you can first identify that which one is having a less load. Based on that, you can just forward the request. Or the other is distance. Likewise, there are many parameters which actually gives you the solution of this kind of problem. So here actually URL rewriting is a scenario where we are not actually providing the entire request content to the customer, but we are simply providing the first page from the original server and then the rest of the content from the surrogate server. So here you can see this is a scenario which I am discussing here. So here this request is made to access something from here. Okay, then it will ask to this. This is a CDN kind of controller, you can say. Okay, Now it has to, now it will ask, it want to access the server. So the request is going to server will divert to this CDN. Now it has to identify which is closer. So it will do some kind of routine exercise. It will just check who are the nearby servers, and then it will find out a round trip time to this customer. So it will ping and find the round trip time, and based on the result, this server will give the result. And now this will decide which is good for this user. And let's say it's fine that this is a good means nearby to this user. It will find and give the IP of this server to this machine, and then it will send it here. That means now it has to communicate to this machine, not to this machine. And now the further communication will be done through this. Full site delivery and partial site delivery means, so this means how you are going to replica or duplicate the content. Are you doing the full site or partial? What does it mean? Just have a look here. Let's say this is the origin server, and then it has gone to the CDN services. These are the surrogate servers. They are keeping the replica. So now these are the users, and this is a controller who has the information of all the servers and the location. So whenever the request has made, it want to access this yahoo.com, let's say. So it will go to this server. It will just divert, and this will direct and say, instead of going to this, just access this and the nearest one. Now this is partial site delivery. So here we are assuming, in the previous case we assumed that the entire thing had replicated fully. Now partially means whenever the first request is made, it is always made to the original server. Okay, and then after, once the initial page has been passed, after that all the objects, images that to be provided onto the page, or the other data that provided, which is of heavy size, will be provided by the surrogate server. So what does it mean? It means, so let's say it will it will not fully replicating, but partially replicating. So it provided all the images here to the server. So whenever this client want to make a request, it will send a get request to access some page. There's a index.html, and then it will get a reply, and then it will make a request to get all the data, all the images of this page to this DNS. DNS will ask to this, and then it will be replied that you have to pass the address of this server, and then it is passed to this. It's all happening based on some algorithms. Some algorithms are working behind this. So what contents are suitable? Like all the heavy kind of images, all the static kind of data will be suitable. Not suitable, your personalized data, secure content, and highly dynamic content, which are changing very frequently, then it's not good for go for the CDN. Okay, it will be very, very costly, because whenever you are accessing data through the CDN, you are paying for it. The company is paying for it. So caching and CDN, the differences are like CDN is basically a very planned, very well planned infrastructures, and it will improve the quality of service. It will give a full control to the content provider, how to manage the data, how to update the data. But in the caching, we don't find this kind of thing. Some vendors of CDN are like Akamai, Rackspace, Google Cloud, then we have Azure Cloud, CDN. So this is mainly used when you have a static content, then only it has more meaningful. If you have a highly dynamic contents are there, then it is not good. And also it is not used for anything which involves authentication. Then we have Amazon CloudFront. So CDN structure we understood. Now how it is provided by the Amazon. So Amazon is providing the CDN kind of services with this CloudFront. So CloudFront is a CDN at the AWS.